Hello, my name is Wenday, and today we are here at wonderful PowerPoint presentation to learn how to balance a chemical equation. This is a generic chemical equation. It's called that because the letters don't actually represent any chemicals, they are just generic letters. On the left side are your reactants. They go into the chemical equation. On your right are your products. They go out of your chemical equations. In between the reactants are plus signs. In between the products are also a plus sign. They indicate that both of the things that are around it are on the reactant or product side. In the middle is an arrow. It indicates that the reactant goes to the product. Sometimes the arrow looks like this or this. That means that the chemical reaction is reversible. There's also a few more things like these. Anyway, here's another generic chemical equation. As you can see, there are numbers now. The little number next to the A is called a subscript. It indicates that two A's are bonded together in a molecule. Over here, the large numbers are coefficients. They indicate that two B atoms and two AB molecules exist and are in the chemical equation. If you see two chemical symbols next to each other, then that means they are bonded. Here is a visual of that generic chemical equation you just saw. As you can see, the A's are bonded together in a molecule while the B's are separate. The AB molecules are together, and there's two of them, as indicated by the coefficient. Now, the main thing about balancing chemical equations is that you want the same amount of each chemical species. Here the chemical species are A's and B's on each side. According to the counting box, there are two of each chemical species, A and B, on each side of this generic chemical equation, which means the equation is balanced. However, if we remove one of the AB molecules, then the equation becomes unbalanced. This is not good. In addition, if you see a coefficient next to things with subscripts, that just means that the things with subscripts are bonded together, and there are multiple. Yep. Okay. Here is how to balance an unbalanced chemical equation. This will be of grave importance to you. Essentially, do you notice how there are different amounts of each chemical species on each side of the chemical equation? That's not good. You will have to do math following these rules to make them balanced. The rules are that you can only change the coefficients, you cannot change the subscripts. Changing the subscripts will result in an entirely different chemical reaction, and that's not good. You also can't have decimal or fraction coefficients, because you can just multiply those proportionally to get a natural number anyway, so what's the point? Natural numbers are funky. Right, so anyway, I assume this was enough time to figure it out. Now, as you can see, there are the same amount of each chemical species on each side, and they are balanced. Also, I'm not sure if atoms existing both like monotomically and diatomically is a thing, but I don't really care. The hypothetical B particle, that's just one of its properties. Anyway, here's how to translate this into real chemical reactions. Do you see this generic chemical equation? Well, it too can be real chemicals. These chemicals are chlorine and sodium, bonding together to make sodium chloride. Wow. Anyway, do you remember this from earlier? Well, I don't. Anyway, what if it was more complicated? Do you see the parentheses around the CD2? That indicates that there are multiple groups of CD2, 3 as indicated by the coefficient. That's not a coefficient, that is a subscript, as indicated by the subscript next to the parentheses. That means there are a bunch of CD2 bits attached inside of the A2B2CD2 3 molecules, of which there are 2 as indicated by the coefficient. In addition, here are some practice problems. I hope that was enough time to do the practice problems. Goodbye.